The U.S. Bureau of Reclamation projects in 2 years' time, Lake Mead may be set to be at its shallowest levels in recorded history.
The Bureau released its 2- and 5-year projections earlier this year, showing levels hovering at about 1,000 feet.
For years, Lake Mead wasn't just shrinking, it was slipping towards something far more dangerous. By the early 2020s, scientists weren't debating if the reservoir was in trouble anymore. They were debating how close it was to failure. Water levels had been dropping steadily for more than a decade, but between 2016 and 2022, the decline accelerated in a way that alarmed everyone watching. Month after month, the shoreline pulled farther back, revealing pale rings of rock that marked where the water used to be. Those rings became known as the bathtub ring, and they weren't just ugly, they were a warning etched into stone. By mid-2022, Lake Mead had fallen to roughly a quarter of its capacity. At that point, the concern wasn't boating, tourism, or even aesthetics. The fear was something far more serious. Dead pool. That's the point where water levels drop so low that nothing can flow downstream. No drinking water deliveries, no hydroelectric power, no safety margin at all. Once a reservoir hits that stage, recovery isn't guaranteed. In some scenarios, it becomes practically irreversible. Behind the scenes, emergency measures were already underway. Massive low-level pumping stations, never meant to be permanent solutions, were activated just to reach water that was no longer accessible through normal intake systems. These weren't upgrades, they were lifelines, quiet acknowledgments that the system was operating on borrowed time. The consequences rippled outward fast. Boat ramps closed, marinas sat stranded in dry air, fish habitats collapsed as water temperatures climbed and oxygen levels dropped. Wildlife that depended on stable shorelines vanished or migrated. Even cities felt the pressure, as officials warned residents that water restrictions were no longer hypothetical, they were inevitable. And hovering over everything was a deeper realization that made this moment different from past droughts. This wasn't just a dry year or even a dry decade. The Colorado River Basin, which feeds Lake Mead, was experiencing one of the driest multi-decade periods in recorded history. The assumptions that built the modern Southwest, steady snowmelt, predictable runoff, reliable storage, were quietly falling apart. For water managers, the math stopped working. Demand kept rising, supply kept shrinking, and the buffer that once absorbed mistakes was gone. Every foot of water loss mattered. Every projection looked worse than the last. So when officials warned that Lake Mead could soon hit its lowest level ever recorded, it wasn't drama, it was diagnosis. The lake wasn't just low, it was dangerously close to the edge. And that's what makes what happened next so unsettling, because just as the crisis seemed unavoidable, the numbers suddenly changed. Just when it seemed like Lake Mead had run out of room for good news, the data took a turn no one was prepared for. At the start of 2023, forecasts from the United States Bureau of Reclamation painted a grim picture. Models showed the lake continuing its slide. Another drop of nearly 20 feet was expected. The logic made sense. Demand was still high. The basin was still dry. Nothing fundamental had changed, except it had. Instead of falling, the lake began to rise, slowly at first, then faster. By mid-year, gauges showed something that hadn't appeared in projections at all, a gain of more than 20 feet. That wasn't a minor correction, it was a full reversal. For scientists and water managers, this wasn't relief, it was confusion. Satellite images started to tell the story before the numbers did. Water crept back into coves that had been dry for years. Marinas that were once stranded in dust found themselves touching water again. Boat ramps reopened. Channels that had been marked closed indefinitely suddenly became usable. To the public, it looked like recovery. To experts, it looked like something was off, because even with that dramatic rise, Lake Mead was still nowhere near healthy. More than 160 feet of water was still missing. The reservoir remained far below full capacity. One good season hadn't erased a decade of loss, it had simply interrupted it. What made this rise unsettling wasn't just its size, it was how wrong the forecasts had been. These models weren't guesses. They were built on decades of hydrological data, climate trends, and system-wide assumptions. And yet, reality had completely broken from expectation. That raised a dangerous question. If experts could be this wrong about the decline, what else might they be missing about the rise? Because sudden gains can be just as destabilizing as slow losses, especially in a system that's been stretched to its limits for years. And the truth was, this water hadn't appeared by magic. It came from a single source, one that would soon explain both the miracle and the risk behind it. The answer to Lake Mead's sudden rebound wasn't hidden in policy or technology. It fell from the sky. During the winter of 2022 into early 2023, something extraordinary happened across the Rocky Mountains. Storm after storm dumped snow at levels rarely seen in modern records. By spring, snowpack measurements in key mountain basins weren't just above average. They were off the charts. That snow mattered because snowpack acts like a delayed reservoir. Instead of rushing into rivers all at once, it melts slowly as temperatures rise, feeding the system over months. And in this case, the melt fed directly into the Colorado River, the lifeline of Lake Mead. As spring turned to summer, runoff numbers kept climbing. Forecasts had to be revised again and again. Rivers that were expected to trickle surged instead. Reservoirs upstream began filling faster than planned. Even Lake Powell, which had been in its own crisis, jumped more than 50 feet in a single year. This wasn't just good snow. It was a rare alignment of conditions. Cooler spring temperatures slowed the melt just enough to prevent massive flooding while extending inflows deep into summer. Rainfall patterns added more water on top of the melt. Evaporation, normally a silent thief in the southwest, stayed lower than expected. Together, these factors created a perfect setup for water to finally reach Lake Mead in volume. But here's the part that made scientists uneasy. This wasn't a trend. It was a spike. Climate records show that years like this don't erase long-term drying. They interrupt it. The same climate system that delivered record snow is also driving higher temperatures, longer heat waves, and faster evaporation across the region. In other words, the very forces that made this year possible are also making future years harder to predict. Water managers knew this snowpack had limits. Once it melted, it was gone, and there was no guarantee the next winter would come close to repeating it. That's why, even as the lake rose, experts resisted celebration, because relying on rare weather events is not a strategy, it's a gamble. And while everyone was watching the surface climb, few noticed what that rising water was beginning to touch. As the water crept back into Lake Mead, it didn't just reclaim empty shoreline. It began touching things that hadn't seen water in decades. During the long years of decline, vast stretches of the lake bed were exposed to open air. What most people saw were cracked mudflats and bleached rock. What scientists saw was something more troubling. A landscape quietly collecting risk. Old industrial sites, abandoned mining residues, chemical residues left behind from eras when environmental rules barely existed. When the lake was low, many of these areas seemed inert, dry, contained. But rising water changed the equation. As shorelines flooded again, substances that had been locked in soil and sediment were suddenly submerged, dissolving, spreading, and moving with new currents. That's when concern turned into urgency. Researchers warned that reflooded sediments can release heavy metals and toxic compounds back into the water column. Not all at once, slowly, unpredictably, and unevenly. The kind of contamination that doesn't trigger instant alarms, but quietly degrades water quality over time. And it wasn't just chemistry. The returning water disturbed decades of settled sediment on the lake floor. Fine particles that had lain still were lifted and redistributed, clouding habitats and interfering with the delicate balance aquatic life depends on. Fish populations already stressed by years of low oxygen, rising temperatures, now faced the shifting environment they weren't adapted to handle. Then there were the physical dangers. As the lake rose, it partially submerged old debris, foundations, rusted equipment, forgotten structures, leaving hazards just beneath the surface, invisible to boaters, dangerous to wildlife, hard to track in a reservoir as vast as this one. Navigation routes that reopened came with new risks that didn't exist before. What made this moment especially unsettling was the realization that recovery itself was exposing the damage of the past. The lake wasn't just refilling, it was reawakening everything that had been buried during its decline. And while contamination and debris posed immediate threats, another danger was quietly gaining ground, one that thrives in disturbed ecosystems and changing conditions. When Lake Mead began rising again, the changes didn't stop at the shoreline. They rippled outward through the ecosystem, triggering a chain reaction that scientists know all too well, but rarely get to observe in real time. Ecosystems don't like sudden change. They adapt slowly over years, sometimes decades. Lake Mead's plants, fish, and microorganisms had already been forced to adjust to shrinking water, rising temperatures, and declining oxygen levels. Then, almost overnight, the rules changed again. Water depth increased. increased, temperatures shifted, currents returned to areas that had been stagnant for years. That kind of disruption creates opportunity, but not always for the right species. Invasive plants and animals are especially good at exploiting instability. Warmer water combined with freshly flooded terrain creates ideal conditions for non-native species to spread faster than native ones can respond. Once established, these invaders don't just coexist, they crowd out local species, alter food chains, and permanently reshape habitats. For fish populations, the stress compounds. Spawning grounds that had adapted to low water conditions were suddenly altered. Sediments stirred up by rising levels reduced water clarity, making it harder for some species to feed and reproduce. Others were forced into deeper zones where oxygen levels fluctuate unpredictably. Birds and shoreline wildlife faced their own challenges. Nesting areas that had become stable during the low water years were submerged again. Food sources shifted location. Migration patterns were disrupted. What looked like renewed abundance from afar was, on the ground, a scramble for survival. Even algae responded to the change. Nutrients released from disturbed sediments fed sudden blooms in certain zones, raising the risk of water quality issues that don't always show up immediately but can worsen over time. The unsettling truth is this: refilling a reservoir doesn't reset the ecosystem, it reshuffles it. Each rapid change stacks on top of the last, creating a system that's constantly reacting instead of stabilizing. And the more unstable it becomes, the harder it is to predict which species will thrive and which will quietly disappear. While scientists track these ecological shifts with growing concern, human systems were facing their own version of the same problem. Because as nature struggled to adapt, people realized something uncomfortable. The infrastructure built for a shrinking lake was now colliding with a rising one. As Lake Mead shifted from collapse to sudden rise, human systems were forced into an awkward reversal. The very tools designed to survive extreme drought were now being tested by a recovery no one had planned for. During the lake's lowest years, officials scrambled to keep water flowing at all costs. Massive low-level pumping stations were rushed into operation. Engineering projects meant to reach water that traditional intakes could no longer access. They worked, but they were never supposed to define the future. They were emergency measures built for a shrinking reservoir. Now, those same systems had to be reevaluated. As water levels climbed, docks, pipelines, and intake structures built for historic lows suddenly sat at the wrong depths. Marinas had to be repositioned again. Access points reopened, but not safely. Infrastructure that had been retrofitted in crisis mode no longer matched the lake's new reality, forcing rapid adjustments under pressure. Beyond hardware, the human response grew more drastic. Cities that depend on Lake Mead began making decisions that would have been unthinkable just a decade earlier. Some voluntarily gave up water they were legally entitled to use. Tucson, for example, agreed to leave tens of thousands of acre-feet in the system each year, choosing long-term stability over short-term access. Other states pushed even harder. In Nevada, lawmakers explored measures that would allow water authorities to cap residential water use at levels far below historical norms. The idea wasn't popularity, it was survival. Officials openly acknowledged that individual consumption habits could no longer be treated as untouchable. Behind closed doors, negotiations intensified across the basin. The old rules rooted in the Colorado River Compact were straining under modern reality. Agriculture, cities, tribal nations, and energy producers all depended on the same shrinking margin of error. And even as cooperation increased, tension grew. Every gallon saved by one group meant pressure on another. Every conservation success highlighted how close the system was to its limits. The rising water offered breathing room, but it didn't solve the underlying imbalance between supply and demand. What made this moment especially dangerous was the illusion of control. The lake was rising, but the fixes were reactive, not permanent. Water managers weren't guiding a stable system, they were constantly adjusting to one surprise after another. And that left scientists with an uncomfortable question. If human planning couldn't keep up with the changes, how reliable were the predictions guiding those decisions in the first place? By the time Lake Mead began rising, scientists weren't celebrating. They were rechecking their math. For decades, water planning in the American Southwest relied on forecasting models built from historical patterns. Snowfall, runoff, evaporation, demand, all fed into equations that shaped billion-dollar decisions. The problem is, those equations were designed for a world that no longer exists. Many of the core assumptions behind today's models trace back to data collected during unusually wet periods in the early 20th century. That means the baseline used to divide water across the region was already optimistic from the start. Modern measurements now show the Colorado River system carries less water on average than planners once believed. Then climate change rewrote the rules entirely. Warmer temperatures increase evaporation, snow melts earlier, rain falls in shorter, more intense bursts instead of steady patterns. Even when precipitation totals look healthy on paper, less of that water actually makes it into reservoirs. Some soaks into dry soil, some evaporates before reaching rivers, some never arrives at all. This is where confidence breaks down. The same system that produced record snowpack one year can swing violently in the opposite direction the next. Long-term forecasts become fragile. Short-term predictions improve, but they don't solve planning problems that span decades. Water managers are left making high-stakes decisions with incomplete information. Even advanced monitoring doesn't fully close the gap. Satellites, sensors, and real-time data streams now track snow depth, soil moisture, and river flow with incredible precision. But translating that data into reliable long-range outcomes remains a challenge. Small changes early in the system can cascade into massive differences downstream. What worries scientists most isn't being wrong once. It's being confident and wrong. The unexpected rise of Lake Mead exposed just how quickly reality can diverge from expectation. If forecasts can miss a 40-foot swing in either direction, then certainty becomes dangerous. Planning shifts from prediction to risk management, preparing not for one future, but for many. And as uncertainty grows, so does pressure. Because hanging over every scientific debate is a deadline that doesn't move. A moment when the rules governing this entire system must be rewritten, whether anyone is ready or not. And when that moment arrives, the future of Lake Mead won't be decided by water levels alone. All of this uncertainty funnels toward a single unavoidable moment. By 2026, the rules that govern who gets water from the Colorado River system must be rewritten. The agreements holding the West together were drafted for a different climate, a smaller population, and a river that was assumed to be far more reliable than it's proven to be. As that deadline approaches, the rising waters at Lake Mead have created a dangerous sense of pause. Not relief, hesitation. States that rely on the reservoir are now locked in negotiations where every side knows the truth, but no one wants to say it out loud. There simply isn't enough water to satisfy everyone the way it once did. Agriculture, cities, tribal nations, ecosystems, and energy producers are all drawing from the same shrinking margin. What makes this moment explosive is timing. The recent rise has bought breathing room just long enough to delay hard choices. Cuts that once felt inevitable now feel negotiable. Urgency softens, compromise slows, and history shows that when difficult decisions are postponed, the consequences don't disappear, they compound. Some proposals on the table would have been dismissed as unthinkable only a few years ago. Redesigning dam operations, rerouting flows, permanently locking in reductions that reshape entire regional economies. These ideas are no longer French. They're being openly debated because the system is running out of alternatives. And yet, even the most aggressive plans share the same weakness. They all assume a future that can be predicted. Scientists warn that this is the greatest risk of all. Not drought, not floods, not contamination, but the belief that the next decade will behave anything like the last. Climate variability has turned planning into a moving target, or solutions must survive extremes at both ends. The lake's rise didn't resolve this tension. It exposed it, because the higher the water climbs, the more pressure builds beneath the surface. Political, environmental, and human. And that leaves one final question that no model can answer. Is Lake Mead recovering, or is it just revealing how fragile the entire system has become? From a distance, the story of Lake Mead looks almost comforting. The water is higher, boat ramps are reopening, the headlines sound less urgent than they did just a year ago. But beneath that surface, nothing fundamental has been fixed. The lake is still far from full. The river that feeds it still delivers less water than the system was designed to use. The climate driving these extremes is becoming more erratic, not more stable. And the recent rise, as dramatic as it was, depended on conditions that may not repeat for decades. In many ways, this rebound is more dangerous than the decline that came before it. Low water forced action. It exposed limits. It made the crisis impossible to ignore. Rising water, on the other hand, creates hesitation. It invites delay. It tempts leaders and communities to believe there's more time than there really is. At the same time, the refill has brought old problems back into play. Buried contamination, ecological stress, fragile infrastructure, and unresolved political battles. Recovery didn't wipe the slate clean, it uncovered what was hidden. Lake Mead's story now sits at a crossroads. One path leads toward cooperation, adaptation, and acceptance of a new reality where water is managed with humility and restraint. The other leads toward complacency, trusting rare weather events to save a system already stretched to its breaking point. The lake isn't sending a message of safety, it's sending a warning in disguise. Because the greatest threat to Lake Mead was never just running out of water. It was believing that a temporary rise meant the danger had passed. And whether that warning is heard will decide the future of the entire Southwest.
Here's the truth most headlines won't say. The rise of Lake Mead didn't solve a crisis, it paused it. Every major vulnerability is still there. The river is still overallocated, the climate is still warming, the forecasts are still fragile, and the system is still built on assumptions that no longer hold. The only thing that changed was the waterline. What comes next won't be decided by snowstorms alone. It will be decided by whether leaders act while there's still room to maneuver or wait until the lake falls again and forces their hand. It will be decided by whether conservation stays in place during good years, not just bad ones. And it will be decided by whether short-term comfort is allowed to override long-term survival. Because history shows this pattern clearly. Crisis triggers action. Relief triggers delay. Delay magnifies consequences. Lake Mead is giving the Southwest a narrow window, not of safety, but of choice. A chance to redesign how water is shared, valued, and protected before the next swing hits harder than the last. The water is higher for now, but the warning hasn't gone away. It's just quieter, and that may be what makes it most dangerous.
There's an uncomfortable reality surrounding Lake Mead that almost no one wants to confront directly. The system was never designed to survive the world we live in now. When Lake Mead was created, the assumptions behind it felt reasonable. The Colorado River was believed to be abundant. Snowfall patterns were relatively stable. Populations were smaller. Demand grew slowly. The idea that the river itself could permanently shrink wasn't seriously considered. That assumption shaped everything: dams, canals, cities, agriculture, power grids. Entire economies were built on the belief that the water would always be there if managed correctly. But the last 2 decades shattered that belief. What scientists now understand is that the Colorado River system is entering a new phase, one where extremes are not exceptions but the baseline. Longer droughts, hotter summers, sudden floods, snow years that save the system briefly, followed by dry years that erase those gains faster than anyone expects. And that creates a future filled with choices most people aren't ready for. One of those choices is permanent reduction. Not temporary conservation, not emergency cutbacks, but long-term acceptance that less water will be available forever. That reality collides head-on with growth. Cities continue expanding. Farmland still demands massive volumes of water. Power generation depends on consistent reservoir levels. Every sector assumes someone else will absorb the loss, but math doesn't negotiate. As water availability shrinks, something must give. And history shows that when resources tighten, the pressure doesn't spread evenly. It concentrates. Smaller communities feel it first. Ecosystems absorb damage silently. Political power determines whose taps stay on longest. This is where the illusion of recovery becomes especially dangerous. Because rising water creates the impression that the system can still rebound on its own, that patience will be rewarded, that nature will correct human overreach if given time. But Lake Mead's rebound wasn't nature correcting anything. It was nature pausing the consequences. And pauses end. Another hard truth lies beneath the surface. Even perfect cooperation won't restore the past. No agreement can bring back 20th century river flows. No infrastructure upgrade can undo decades of warming. The best-case scenario now is managed decline, not abundance. That's a difficult message to sell. It requires leaders to admit limits, communities to change habits, industries to adapt or shrink. And humans are notoriously bad at responding to slow-moving threats, especially when there's just enough relief to delay action. What makes this moment unique is timing. Lake Mead rose just enough to calm panic, but not enough to fix anything. That creates a narrow window where planning can happen without desperation, if people choose to use it. Once the next downturn begins, choices become reactive again, harder, more divisive, more damaging. Scientists worry that the next drop could come faster than expected. Warmer winters mean more rain instead of snow. Earlier snowmelt means less water reaches reservoirs. Higher evaporation eats away gains before they're even measured. Each of these factors compounds the others, and when they align, losses accelerate. There's also the question no one likes asking. What happens if recovery never comes back this strong again? If the 2023 snowpack turns out to be an outlier instead of a preview, then the recent rise may represent the last major refill event for a generation, not the beginning of a turnaround, but the final warning shot. That possibility changes everything. It reframes Lake Mead not as a reservoir bouncing back, but as a system flashing its final indicators before settling into a new, lower equilibrium, one where scarcity is normal and abundance is remembered. And yet, the future isn't fully written. Lake Mead still holds leverage. Water saved today compounds tomorrow. Agreements reached early prevent conflicts later. Investments made now cost less than emergency fixes later. The lake's rise has created a rare moment where planning can outpace panic, but only if the illusion is recognized for what it is. Because Lake Mead didn't rise to tell us everything is fine. It rose to show us exactly how fragile the system has become and how quickly that fragile balance can shift. The question now isn't whether the water will fall again. It's whether the people who depend on it will be ready when it does.
If you stand at the edge of Lake Mead today, it's easy to believe the danger has passed. The water looks calmer. The shoreline feels closer. The crisis sounds quieter. But that calm is deceptive, because Lake Mead is no longer just a reservoir. It's a signal, a live experiment showing what happens when a system built for certainty collides with a future defined by instability. For decades, people believed water scarcity would arrive suddenly, a dramatic collapse, a visible breaking point, something impossible to ignore. What actually happened was slower, quieter, and far more dangerous. The system bent instead of breaking. It absorbed stress. It adapted just enough to survive. And in doing so, it hid how close it came to failure. That's what makes the recent rise so unsettling. Not because it happened, but because of how easily it changed the conversation. Panic faded. Urgency softened. Hard questions were postponed. The same behaviors that pushed the system toward collapse were allowed to continue, just slightly adjusted, slightly delayed. And this is where history becomes a warning. Every major resource crisis follows the same pattern. Early signals are ignored. Emergency measures are celebrated as solutions. Temporary relief is mistaken for recovery. And by the time the damage becomes undeniable, the options are fewer, harsher, and more divisive. Lake Mead is sitting precisely at that point right now. The science is clear, even if the future isn't. The river delivers less water than it used to. The climate no longer behaves predictably. Demand continues to rise. None of those realities changed when the lake rose 20 feet. They were simply masked. What lies beneath the waterline today isn't just sediment and debris. It's unresolved tension, political hesitation, environmental debt, decisions deferred instead of made. And the lake remembers all of it. Every drop added this year carries a reminder of how rare this moment is. Every foot gained highlights how much was lost before and how quickly it could happen again. The system doesn't reset, it accumulates consequences. That's the part people miss. Lake Mead isn't asking whether humans can react to disaster. It's asking whether they can act before disaster returns. Because the next crisis won't announce itself with headlines. It will arrive quietly, through lower snowpack, higher heat, faster evaporation, and shrinking margins that only experts notice at first. By the time it becomes obvious, the window will already be closing. The lake has shown us two futures. One where temporary recovery breeds complacency, and another where warning signs are taken seriously while there's still time to respond. The water level will rise and fall again. That much is inevitable. What isn't inevitable is how prepared we'll be when it does. And that may be the most important thing Lake Mead has revealed. Not how fragile the system is, but how little room remains for pretending everything is fine.